study of thin layer dryer. This is the thin layer dryer sweater. It consists of a container which can be called as a chamber, where we are going to place a sample which we are going to dry. It contains three trays. We have to place 10 grams of sample in each tray for drying purpose. The main aim of this experiment is to measure the efficiency of this thin layer dryer. First, we have to start the blower. It consists of a blower, and these two parts are the inlet for transferring the hot or for drying purpose. This is a blower which is attached with the motor. We can also control the speed of the motor by using the attachment. Using this attachment. And here, this is the opening valve and closing valve of the blower. If the valve is in open position, the air flow will be passed through this two inlet, and we can also close the valve for a particular time to chill out the placed sample. First, we have to select the temperature of the blower, which can be set in this digital meter. By setting setting the temperature here, we have to, after setting the temperature here, we have to close the valve. After attaining that particular temperature, then we have to open the valve for the circulation in the chamber area. By giving the hot air only, we can get a proper result. If we blow dry air or less hot air or not normal air, it won't get dry easily, and the process will take a lot of time to get dry. We have to note down what are the parameters we are going to note down for temperature of the both inlet and this constant temperature. Then moisture content of the sample from the beginning to the end for the interval of 10 minutes. For the calculation part, we can see in for calculation, we have to note down the initial weight of the sample at after 10 minutes and final weight of the sample after 10 minutes. This is initial weight and final weight. And then internal temperature of the air, which will be set in which we can note down from the digital meter, and temperature of the hard air. As we seen in that equipment, there is two outlet. First, on the right side, it is inlet portion, and the left side, it is the outlet portion. So from the temperature sensor, we can note down this temperature. For calculation, first we have to note down the initial moisture content of the grain. For identifying the initial moisture content of the grain, we can directly use the moisture meter. We can directly use this moisture digital meter. From this, we can identify the moisture content of the sample. Then for individual moisture content, to identify the individual moisture content at a regular time interval, which is 10 minutes, 20 minutes, 30 minutes, we have to calculate this from the formula initial mass of the grain minus final mass of the grain at that particular temperature, and bone dry material. This is total material get dried at that temperature at that time. Simply we can explain as first we are going to take initial weight as a 10 gram, and after drying for 10 minutes it comes to 9.8 grams. Here the bone dry material will be 9.8 gram. For next from 9.8 gram it comes to like 9.2 grams means here the difference will be calculated as 0.6 gram. So the bone dried material will be 0.6 grams plus 0.2 grams. Sorry, here it will come as 0.2 gram. 0.2 plus 0.6 gram, which will be 0.8 grams. This is our bone dry material at 20-minute time interval. So for following this process, we have to calculate for this remaining temperature time interval. Then we are going to calculate the drying rate at time interval. For drying rate, we having the formula as mass of water removed at time t in kg divided by time taken. That means for first calculation you will put as a 10, and second calculation either again the difference between the time is 10 minutes. So we have to convert the 10 minutes into hour and then substitute here. Following the same procedure, we have to find all the drying rate of these values. Then for total dry rate, the total dry rate will be sum of individual drying rate, which we calculated here. Afterwards, we can identify the drying rate of the thin layered dryer. Then we are going to find the equilibrium moisture content. How much moisture can be reduced from the total process? We are going to find that. For that, we have to note down the moisture content of the material at the taken time interval. M naught will be your initial moisture content. For measuring the moisture content, we can directly use the digital moisture content meter. Then final moisture content at a particular interval of time, we are going to measure it separately. By using this, from the formula M minus ME, which is final moisture content divided by initial moisture content minus final moisture content. In the this M will be taken from the already published data which will be available in the net. We have to take down that. We have to take down the value from there. We can consider for if it is a paddy sample or if it is any other grain, for it will be approximately 12%. So we can use a moisture content as 12. This data will be available in ICAR websites. From that, we are going to find the moisture content, equilibrium moisture content rate for individual time intervals, and then we are going to calculate the sum of the equilibrium moisture content removed from the grain. Then we have to draw a graph which will be plotted against time and drying rate of the sample. That's it. Thank you.